small asteroid fragments.
An asteroid on a collision course to planet Earth? It may sound straight out of a science fiction.
Space is vast, it's bigger than we can imagine, but it's not empty. Asteroids hurtle through the solar system. Some come close to Earth. Asteroid 2024 YR4 was one such asteroid. At first, astronomers thought it might hit us. They calculated a 3.1% chance of impact. That's a 1 in 32 chance. Thankfully, the odds changed. With more observations, the risk decreased. It dropped to 1.5%, then 0.28%. That's a 1 in 360 chance, still a bit unnerving, but much better than before. So, why the change? Why do these predictions shift so much? Let's explore the fascinating world of asteroid tracking. Imagine throwing a dart at a dartboard. Now imagine the dartboard is millions of miles away. That's the challenge astronomers face when tracking asteroids. These space rocks are small and dark. They're hard to spot against the blackness of space. Astronomers use powerful telescopes to find asteroids. These telescopes scan the sky. They look for moving points of light. Once they find an asteroid, they track its movement. They take multiple images over time. This helps them plot the asteroid's path. But here's the catch. Early observations are often limited. We might only see a small part of the asteroid's orbit. It's like trying to predict the dart's path after seeing only a fraction of its flight. As we gather more data, the picture becomes clearer. More observations mean a more accurate trajectory. Think back to the dart analogy. Imagine seeing more of the dart's flight. You'd be better able to predict where it will land. Astronomers use sophisticated software to refine their calculations. They input the new observations. The software adjusts the asteroid's projected path. This process is ongoing. Each new observation helps us refine our understanding of the asteroid's orbit. In the case of asteroid 2024 YR4, continued observations significantly altered its projected path. The initial estimate of a 3.1% impact probability was based on limited data. As more observations came in, the projected path shifted and the impact probability plummeted. The size of an asteroid plays a crucial role in assessing its potential threat. Larger asteroids pose a greater risk. Asteroid 2024 YR4 is estimated to be between 130 and 300 feet wide. While that's smaller than many asteroids, it's still large enough to cause significant damage if it were to impact Earth. To put it in perspective, the asteroid that wiped out the dinosaurs was about 6 miles wide. Asteroid 2024 YR4 is significantly smaller. However, an impact could still devastate a city or a small country. The good news is that smaller asteroids are also less likely to survive entry into Earth's atmosphere. Our atmosphere acts as a shield, burning up most smaller space rocks before they can reach the ground. Understanding the Torino scale. With all these potential threats whizzing around in space, how do we make sense of the risk? That's where the Torino scale comes in. It's a tool astronomers use to communicate the potential hazard of an asteroid impact. The Torino scale ranges from 0 to 10. 0 means no hazard at all. 10 means a certain collision with global consequences. Each level has a corresponding color code, making it easy to understand the level of risk at a glance. The scale considers both the likelihood of an impact and the potential energy of the impact. A large asteroid with a low probability of impact might have the same Torino scale rating as a smaller asteroid with a higher probability of impact. Levels of concern. Asteroid 2024 YR4 made history as the first asteroid to be officially classified as Level 3 on the Torino scale. Level 3 corresponds to a close encounter with a chance of impact. It merits attention from astronomers but doesn't necessarily mean an impact is likely. The color code for Level 3 is yellow, indicating a situation that merits careful monitoring. Think of it like a yellow traffic light. Proceed with caution. While asteroid 2024 YR4's classification on the Torino scale initially caused concern, the revised calculations and downgraded risk level highlight the importance of ongoing observation and refinement in asteroid tracking. A history of close calls. Asteroid 2024 YR4 is not the first space rock to cause a stir in the astronomy community. The vastness of space is filled with countless objects, many of which have come alarmingly close to our planet. These celestial bodies, often traveling at incredible speeds, have the potential to cause significant damage if they were to collide with Earth. Throughout history, there have been numerous close calls with asteroids. Some of these near misses have been documented and studied extensively, providing valuable data for scientists. Each close encounter teaches us more about the behavior and characteristics of these space rocks. In most cases, these asteroids have passed by Earth without incident. Their trajectories, while close, have kept them at a safe distance from our planet. However, the mere fact that they come so close is a stark reminder of the dynamic and ever-changing nature of our solar system. However, these events serve as reminders of the potential risks posed by near-Earth objects. The scientific community remains vigilant, constantly monitoring the skies for any signs of potential threats. Advanced technology and improved observation techniques have significantly enhanced our ability to detect and track these objects. One notable example is the asteroid Apophis. This particular asteroid has been the subject of much discussion and concern over the years. Discovered in 2004, Apophis initially sparked concern due to its size and trajectory. Measuring approximately 370 meters in diameter, it was large enough to cause significant damage if it were to impact Earth. It was briefly classified as a level 4 on the Torino scale, indicating a close encounter with a 1% or greater chance of impact. This classification caused widespread concern and prompted further observations and studies. Fortunately, as with asteroid 2024 YR4, further observations of Apophis allowed astronomers to refine its orbit and significantly reduce the estimated impact probability. These refined calculations provided much-needed reassurance to the public and the scientific community. Today, Apophis is no longer considered a significant threat for the foreseeable future. The continuous advancements in our observational capabilities ensure that we remain prepared for any future close encounters. The legacy of 1997 XF-11. The development of the Torino scale was not arbitrary. It was a carefully considered response to a growing need within the scientific community. The scale was designed to provide a clear, understandable way to communicate the potential risks posed by near-Earth objects, or NEOs, to both the public and policymakers. It was born out of a need for clear communication about asteroid risks following a real-life event that highlighted the potential for confusion and panic. This event underscored the importance of having a standardized system to assess and convey the threat levels of asteroids. In 1997, an asteroid named 1997 XF-11 made headlines when initial calculations suggested a high probability of impact with Earth in 2028. The news spread rapidly, causing a wave of concern and speculation. People were understandably worried about the potential for a catastrophic event. The news caused widespread concern and sparked debate about how to communicate such risks to the public. Scientists and media outlets struggled to find the right balance between informing the public and avoiding unnecessary panic. However, as with our previous examples, further observations and refined calculations quickly downgraded the risk. The initial alarm was based on incomplete data, and as more information became available, it became clear that the asteroid would not pose a threat to Earth. Asteroid 1997 XF-11 is now known to pose no threat to Earth. The incident, however, left a lasting impact on the scientific community and the public's perception of asteroid risks. However, the incident served as a wake-up call. It highlighted the need for a reliable system to assess and communicate the risks associated with near-Earth objects. It emphasized the need for a clear and concise system for communicating asteroid risks, a need that the Torino scale now fulfills. The scale has since become an essential tool for astronomers and space agencies worldwide, helping to ensure that the public receives accurate and timely information about potential asteroid threats. Guardians of the Cosmos. The story of Asteroid 2024 YR4 with its fluctuating impact probabilities and eventual downgrade underscores the dynamic nature of asteroid tracking. This asteroid, initially flagged as a potential threat, had scientists around the world on high alert. They meticulously tracked its path, recalculating its trajectory with every new piece of data. The process was intense, involving countless hours of observation and analysis. It's a constant process of observation, calculation, and refinement. Each observation provides new data, which is then used to update models and predictions. This iterative process is crucial in ensuring the accuracy of our predictions. The dedication and precision required in this field cannot be overstated. As technology advances and our observational capabilities improve, so too will our ability to accurately predict the paths of these celestial wanderers. Modern telescopes and space observatories are equipped with cutting-edge technology that allows us to see further and with greater clarity than ever before. These advancements are pivotal in our ongoing quest to understand and monitor the cosmos. Rest assured that astronomers around the world are constantly scanning the skies, vigilant in their watch for potential threats from space. Their work is a testament to human curiosity and our desire to protect our planet. Every night, these dedicated individuals peer into the vast expanse of space, searching for any signs of danger. The next time you hear about an asteroid making a close approach to Earth, remember that while there's always a chance, it's just that, a chance. The rigorous processes in place ensure that we are well prepared for any potential threats. The likelihood of an asteroid impact is continuously assessed and updated, providing us with the information we need to stay safe. Thanks to the tireless efforts of these cosmic guardians, we can sleep soundly, knowing that someone is always keeping an eye on the skies. Their unwavering dedication and expertise are our first line of defense against the unknowns of space. So, as you gaze up at the stars, take a moment to appreciate the guardians of the cosmos who work tirelessly to keep us safe.